Hello everyone, and welcome to a cosmic event. So powerful that for a few brief moments, one dying star can shine brighter than an entire galaxy. Yes, in our today's video, we will talk about only the brightness produced by a dying star. Only the brightness. Actually, this is a subject matter of astrophysics, and so many things are there. Discussion of quantum mechanics, quantum physics, discussion of particle physics. So many things are involved here. But we will talk about only the brightness produced by a dying star, and that is what? That is supernova explosion. Okay, supernova explosion or supernova burst or only supernova, all are same thing. And supernovae, this is the plural form of supernova. So in the video title you can see that a supernovae burst is there. Okay, that is the plural form of supernova. And whether it is burst, whether it is explosion, or all are same. And even if a burst, explosion, this term is not present, then also the meaning remains the same. So in most of the cases actually only supernova this term is used. So what is actually this supernova explosion or supernova? This happens when a massive star is just about to die, or a massive star is dying. When the massive star is not dying, massive star means what? Means stars heavier than, many times heavier than our sun, at least 8 times. Should be heavier than our sun. Okay, at least 8 times should be heavier than our sun, then only supernova explosion may occur. And it should be, the massive star should be at least 20 to 25 times heavier for the formation of a neutron star or black hole. Anyway, we are not talking about those things here in this video. We are talking about only the brightness produced from a dying star. Okay. Dying star. Dying star means what? You know, in normal condition, nuclear fusion happens. So there are two types of forces at that moment, okay, or during that phase. Two forces are there. Inward pulling force, that is the force of gravity, and outward force, that is due to the nuclear fusion. Pressure, okay. Pressure is exerted in the outward direction, and in the inward direction gravity is there. So when they balance each other, in that case we say that the star is in normal condition. They are balancing each other. Right at this moment our sun is in balancing condition. Okay, there also in our sun also two types of forces are there. Inward, the pulling force, that is the gravity force. Outward force, that is the force due to nuclear fusion. Okay, not fission, nuclear fusion. Anyway, but when the nuclear fuel runs out, what happens at that time? That time outward force becomes absent. There is no outward force, only inward force is there. So rapid contraction occurs. Okay, rapid contraction of the core occurs. So what happens? Density increases at that time, but there is a limit of increasing this density, because due to neutron degeneracy pressure, there is a limit. Neutron degeneracy pressure again, and this is governed by quantum physics. Neutron degeneracy pressure, again there is a repulsive part of the strong nuclear force which is governed by particle physics. That means there is a limit. Due to inward gravity force, the density increases, but there is a limit, maximum limit, beyond which increase in density is not possible. And at that time rebounds occur due to these two types of forces, neutron degeneracy pressure and that repulsive part of the strong nuclear force. Rebounds occurs, and this release, when rebounds occur, this releases an explosion so colossal that it hurls matter and light across millions of kilometers. Yes. And that time here, so we are talking about only the brightness produced by such explosions. So you can consider the brightness of a billion suns. You know our sun. So if you sum up the brightness of a billion sun, then this combined effect of brightness is comparable to the brightness produced from a dying star. Dying star means when the nuclear fuel is exhausted. But when this death occurs, at the same time rebirth occurs. Because during this explosion, few elements are produced like iron, gold, oxygen, and these elements actually seed new planets, new stars, even life itself. So death occurs, explosion occurs means death occurs. At the same time, rebirth occurs. Again, you know that there is a formation of nebula, that is a cloud of glowing gas and dust. This is the afterglow of supernova explosion. Okay, that is a nebula, and from those ashes, stars are born. And this is nothing but that cosmic cycle, eternal cosmic cycle. Okay. So this is not you. So what was the main topic of discussion here? That universe's majestic explosion. The supernova explosion can be considered as the universe's most majestic explosion. Why majestic? Because so much brightness is produced. Okay. I have already mentioned that if you sum up the brightness of a billion stars, billion suns, okay, then that is equivalent to the brightness produced from a dying star. Anyway, so many things are involved here in this topic actually. Formation of white dwarf, red dwarf, then black dwarf. So many things are there, and physics, in-depth analysis of physics is there, but we are not talking about all those things here. Only the brightness and just an idea. Okay. Just an idea. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video interesting, so please like, share and subscribe to our channel. This is it. Thanks for watching.